All right, today we're going to go angles of polygons. Just as a quick review, what is a convex polygon? A convex polygon is any polygon that doesn't have its sides kind of cave in on itself. So you could even have Pentagon that looks like this. Okay. These are convex. Something that's not convex, that's a pentagon that looks like that, where a corner is kind of pointing in towards the polygon. So let's take a look here. We need to find a relationship between the number of sides and the total degrees of a polygon. And when I'm talking about the degrees, we're talking about the inside angles here, the interior ones. All right. And so let's analyze the first one, the triangle, which has 3 sides, and its total degrees is 180. Most of us know that, and remember that from middle school. The next one is a 4-sided figure, which is a quadrilateral. Again, 4 sides, total degrees is 360. The next one is a pentagon, 5 sides, 540 is its total. And hexagon, which is 6 sides, has a total sum of 720. And so what we want to do is let's take a look and see if there's a pattern going on with the total number of degrees, because that's going to help us figure out what the sum of the interior angles is. So, and sometimes I'll write that as interior angle sum. All right, so taking a look from triangle to quadrilateral, quadrilateral to pentagon, pentagon to hexagon. Looking at the total angle, or total degree sum, you notice that it keeps on adding 180. And so from our patterns, if we add by a constant, we can just multiply by it. So we might be thinking, well, 180 times n of course is the number of sides. And so let's check that out. So 6 times 180, that gets me 1,080. 5 times 180, that gets me 900. 4 times 180, that gets me 720. And then from our triangle above, 3 times 180 gets me 540. Well, you might be saying to yourself, this doesn't work, they don't match. But let's take a look and see if there's a pattern going on between those two. And you'll notice that it's a difference of 360 each time. So all we need to do for our formula is make sure that we subtract 360. And now we have the interior angle sum formula. Let's go over some examples. All right, so here's our formula. It says, what is the sum of the measure of the interior angles of an octagon? Octagon, if you remember, is 8. And here we're looking for the sum of the interior angles. So we know that we have to use this formula. 8 our number of sides, which is n. And so we get 180 times 8 minus 360. So interior angle sum equals 1080. Now the next question asks, what's the measure of one interior angle of a regular octagon? Remember that regular means all sides equal and all angles equal. An octagon means that there's going to be 8 sides here. So if I take an octagon, got a little small one here. We have to know that each angle in the octagon is equal. And so, and I'll label it A. So each angle is A. A plus 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 A, which is 8 of them. So 8A. That should equal our interior angle sum. But we have a formula for interior angle sum. Interior angle sum is 180 times n minus 360. And we know what n is. N is 8. So we plug in 8. We get 8a equals, and I evaluate this. Turns out that we get 1080. And then we divide, we think to divide by 8 both sides. And that gets us A equals 135 degrees. So the same thing applies with this next example. Again, what's the measure of one interior angle of a regular decagon? So regular decagon, 10 sides. They all have the same angle, so 10 angles. We'll say that they're A. And that's going to equal the interior angle sum, which is 180 times the number of sides minus 360. And we know that 180 times 10 minus 360, that's going to get us 1,440. Divide by 10 both sides. We get A equals 140. Now, what's the measure of a regular, well, one interior angle of a regular heptagon? Here, we take a look, we've got 7, okay, because there's 7 angles in a heptagon, right? 7. And that's going to equal 180 times 7 minus 360. So, 180 times 7 minus 360, we get 900. And then we divide by 7 both sides. Here we're going to get an estimate. So we get about 128.6 degrees. Okay. So, but it is possible to have decimals as angles, so don't worry about that. The next one asks, how many sides, sides is n, does a convex polygon have if the sum of the interior angles is 1,620? So again, we're going to use that formula. Interior angle sum equals 180n minus 360. But this time, we know what the interior angle sum is. It's 1,620 equals 180 n minus 360. So if I solve this, just like algebra, I'm going to add 360 to both sides, which gets me 1,980 equals 180. And divide by 180. So we get, I should write out what I'm thinking. N equals 11. So an 11-sided figure has an angle, interior angle sum of 1,620. All right. And that's it for today.